In this video, I will teach you everything there is to know about the discriminant of a quadratic equation. First, let's spend a few seconds understanding it, and then I will go through 3 examples with you, plus a bonus tricky question at the end. By the end of it, I guarantee you'll become an expert at using it. So let's begin. So now let's recall the standard form of a quadratic equation. To find the roots or solutions, we'll use the quadratic formula, which is this over here. So I will focus on the term within the square root, b squared minus 4ac. So b squared minus 4ac is known as the discriminant. So the way to use it, right, is very straightforward. Whenever b squared minus 4ac is greater than 0, we have 2 solutions or roots. So just bear in mind roots, solutions, and x-intercept, they are the same thing. So when the discriminant is less than 0, we have no roots. When it is more than 0, there are 2 roots. And when it is equals to 1, there's only 1 root. So 2 roots meaning that the graph will cut the x-axis twice. 1 root means that you cut it once. And no roots means that it will not cut the x-axis at all. So we are done with the introduction. Let's move on to 3 examples. So in this first example, we have y equals to 2x squared plus 3x plus 1. We will write out the standard form so that we can compare the a, b, and c's easily. A is equals to 1, a is equals to 2, b is 3, and c is 1. We will now substitute a, b, and c into the discriminant formula. Where we can see very easily that this equals to 4 minus 8, which is negative 4. So because the discriminant here is negative, less than 0, there are no roots. And so the quadratic graph will not cut the x-axis. So it could look either like this or that. Whether or not it is a parabola or inverted parabola depends on the value of a. If a is positive, then it would resemble a parabola. If it is negative, then it would be an inverted parabola. Now let's move on to the next example, where y is equals to negative 3x squared minus 4x plus 4. So we are going to do the same thing right here. Compare it with the standard form. And you can see that a is 1, negative 4 is b, and c is 4. So let's quickly substitute the a, b, and c values into the formula like as before. And we'll get 16 minus 16, which is 0. So because the discriminant is equals to 0, there's only 1 root. So our quadratic curve would cut the x-axis once, and will either look like this, case 1, or like case 2. So because a is positive, it will look like the first scenario. As for our third example, we have y squared equals to 3x. We have y equals to 3x squared plus 2x plus 5. So again, I'm going to repeat what we have done earlier on for the previous 2 examples. Compare it with the standard form, where a is equals to 3, b is 2, and c is 5. Substitute the values of a, b, c into the discriminant formula. And now we see that we have 2 squared minus and we see that we will get 4 minus 60, which is a negative number. So because the discriminant is negative, less than 0, we have no roots. And the graph will not cut the x-axis. So it will either be 1 or 2. For this question, it will be 1 because a is positive. If you find this helpful thus far, please subscribe as I will be posting similar videos in the near future. So we're done with the 3 questions. Let's move on to our bonus question. Now over here, we see that y is equals to x squared plus 4x plus 4.001. We will now compare this with our standard form. So a is equals to 1, b is 4, and c is 4.001. Subbing this into the formula for the discriminant, we will get the following. So because the discriminant is negative, our quadratic graph will not cut the x-axis. And it will be a non-inverted parabola because a is positive. So this example is tricky because the determinant is very close to 0, which might initially suggest that there could be roots, but it turns out that there are no roots at all.